Hello everyone and welcome to Teardown Hardware. What you see in my screen is Arduino Uno schematic design file. Arduino Uno is an open source project. Access to the design files is open and free on the web. In this video I will deep dive in the schematic file and give a good understanding. The file you're now watching is not easy to explain, therefore I'm going to edit and try to make it more understandable. Since Autodesk has released a new version of Fusion 360, which includes electronics design, I will also take the challenge and edit Arduino Uno schematic with Fusion 360. Autodesk has a free version for individuals, and I will also show step by step how to download Fusion 360, install it, and where to get Arduino files from. I open my browser, visit the official website of Autodesk, click at Products, Fusion 360, go at the Offerings, for personal or hobby use, learn more, get started, enter your email address, your password, your personal information, agree to the terms and conditions, click next, then download Fusion 360 now. Fusion 360 now will start to download. Go to the downloads, and now we have to install it. Double click. For this process to complete, it will take about 15 minutes. I will speed it up on my end to keep this process short. Fusion will open automatically once the setting up is complete. Now I'm going to show you where to download the Arduino schematic and layout files. Go at your browser and type the official website of Arduino Uno. Click enter. Go at the search window, type Arduino Uno and hit enter. Select the Arduino Uno Rev3 board. Now scroll down, click on the documentation, click on the zip file. The zip file will start to download. Go at your downloads, double click, here is the downloaded file. Right click and extract all. The files will be extracted. Importing Eagle files goes as follows. Open Fusion 360. I will create a new project and name it TDH projects. Click enter, and inside this folder I will do the project name folder so it looks more clean. I will create another new folder. I will name it Arduino Uno Rev3 and click enter. I will go inside that folder and then go at files, new electronics design. Now at the project for the electronics design, I have here this option. This is for new schematic, which is not our case, and this is for referencing a schematic document we already have. So I will click here and select from my computer. I am here directed to the downloads, at the files we are going to work with, and the schematic file only is shown. I will select it and click open. Schematic file is open. Now I'm going to the project again. Here I have a new PCB and a reference to the PCB document. So I will do the same. Select from my computer, select the board file, open. Both Arduino files we downloaded from Arduino are now imported. We have to save those files. Click the save button. You check the location of the project, that it's at the project you have already selected, and then click save. Now all your files are shown on the left side. Here is the project file, here is the board file and the schematic. We will only focus in the schematic, and I will make this schematic look better, easy to read, and later explain every part of the schematic. I am going to start by setting up preferences, and that would go at the preferences, the electronics. I prefer to have a large cursor, so I will do large for both schematic and PCB. I'm going to remove the beep. Also the grid I will keep for both display grid, apply, OK. I'm going at the grid here, display on. Now we can start to edit the schematic. The process of editing the schematic takes long, and it does not serve the purpose of this video. While explaining the strategy I'm following here, the editing will play in high speed. There are some things I don't like in this schematic. Long nets going around, labels out of grid and not symmetrically looking. Schematic functional blocks like regulators, microcontroller interface, supply inputs are messed up and there is no clear separation between them. The strategy is simple. I like to keep connectors and USB with only the net label and not directly connected. I will keep every part of the schematic that has its own function separately. I will disconnect it by deleting nets and placing labels instead. In this way, when all schematic function blocks are placed out of the frame and nicely edited, I will start to put them back in, but this time organized. I will place back all the schematic functional blocks in the frame. Starting from the left side of the frame, I will position the supply input and the regulators and the USB. In the middle side of the frame will be the processing, microcontrollers, main and the USB converter. Going to the right side of the display, I will position the connectors for accessing the GPIOs. Once everything is positioned, I will start to separate that by drawing lines in between, and the last will be to name every block separately. This is where we got so far, and we have separated all the schematic blocks, but there is still names missing for each of the functional blocks, and this is what I'm going to do right now. I will do a simple comparison to what we had in the very beginning. The file we downloaded from the Arduino Uno is this one here, and after editing we have this one here. I'm going to write the names for each of the blocks and say some words for each of them. Starting to place the labels, I go at the document and I will choose the layer info and start to write the name. So I will start again from the left side. So the first part here is the DC input jack, which has an input voltage rating from 7 to 12 volt and the 5 volt linear regulator, which could support up to 1 ampere. Coming second on the left side is the MOSFET, which actually selects between the USB and the power coming from the jack, and the 3.3 low noise linear regulator, which supports up to 150 milliampere. This regulator is for cases where you want to use a low noise source for doing more precise measurements. Now I will talk a bit about the selection here. We have a divider which has two equal resistors. This means whatever is in here, we have half of it in here. And the comparator will compare this one with the 3.3 volt. Let's say we have 7 volts in here. This will be 3.5 volts, and this will compare the 3.5 to 3.3, and depend on that will be the power selected from the comparator going to the gate, and will control the gate whether this power comes from the USB or from batteries if we use, or from a power supply. Here we have a signal buffer for the clock signal of the SPI signal, and this is connected to an LED which will blink when you, for example, program the Arduino Uno, the programmer from the SPI interface. And this one here is pretty simple. Here is a capacitor for the supply of the operation amplifier. Next is the USB interface, which could support up to 500 milliampere. It's always nice to write how much current can each input support. In case you're using or more power and you don't know what's going on, you can jump in the schematic, look at it, and find out that this input supply could only support this amount of current. Then next is the USB to serial interface converter, and this is used because the Atmega 328 doesn't have a USB interface, but it only has a UART interface. In order to connect to the USB, which is the most common use of connection now, we use the USB to serial interface converter to interface it. The serial interface converter has also two blinking LEDs. This is why you see the LEDs blinking every time you upload your source code to the Arduino board. This one here is the SPI interface. You can use this in case you design your own Arduino and you want to upload the bootloader with the help of a programmer. The same interface is used here. Then we have the main microcontroller, which is the Atmega 328. This microcontroller is our source code uploaded. Everything happening here happens at this microcontroller. So the Atmega 16U2 only converts the USB interface to an UART interface. Then the main microcontroller has a bootloader, which actually makes it possible to program the Atmega 328 through the UART, and then your code will be running in this microcontroller. And last, on the right side are the pin headers, which we use to connect sensors or signal controlling to the main microcontroller GPIOs. It's always nice to write in the schematic and specify whether this is a male connector or a female connector when you use standard pitch connector. This is all you need to know about the Arduino Uno hardware. So I will again jump on the not edited version and the edited version. Thank you very much for following till the end of this video, and hopefully you have now understood what the Arduino Uno does, and I highly recommend you will also follow the same steps I did and edit the schematic and make it best for you to understand and of course for others to read.